Okay, good morning, everyone. Can you hear me?
Good morning.
Yes, sir.
Okay, excellent. So, hope everyone is fine. Now, welcome to the another week of week 8. Now, this week, last week we covered about architecture and very important things we covered. This week we'll be doing something really interesting, which is very much related to the practical field of software engineering. Okay, before coming to the main point, some basic, homeworking thing. The assessment 2 due on week 11. So in which you have to submit the detailed requirements, architecture, and component design. So basically week 7 and week 4 is required mainly for that report too. Assessment 3 PowerPoint presentation due on week 12. We'll be trying to make it on 12, in which individual presentation will be done. Now, other guidelines are you're expected to work 9 hours per week outside the class, and I'll be available for consultation 1 hour every week. For exact timings, you have to email me. But however, I have classes on Tuesday, Wednesday, and Thursday. So Tuesday, Wednesday, 3 to 4, and Thursday, 11, 12 is the ideal time in Zoom meeting if any group want to do the meeting. And for all communications, but before setting up any meeting, you have to send me an email, which is ACNG205 as the email header, and you can mention the reason of communication, like lecture clarification or the appointment timing. Now, some recap, some review. Week 1, we covered effort estimation. Of course, one of the very important thing for your assessment is the timeline, like how many weeks for which task you need to provide, which is the kind of Gantt chart type thing, plus work breakdown system that we'll be discussing later on, which is similar to that kind of timeline strategy, plus the budget. So those things I'll be covering probably immediately before the assessment 2 on a particular week, probably on week 10 I'll be covering. But week 1 is also kind of required for that particular task that will go to your assessment 2. Week 2, we covered about software engineering process methodology, like the Scrum or XP programming or anything, and the justification that you need to touch on assessment 2 as well, with the proper justification. And the justification, you should give reference from recent research. And for any justification, you try to search for relevant research, and that is basically needed. And then your referencing and your research study seems more appropriate if you use that for a particular justification purpose. Week 3, we covered about complexity and handling complexity of the program. And that week 3 knowledge is bit of, it will repeat today actually, but in a more elaborative way. Week 4 was one of the important lecture, requirements engineering, which is the foundation of software engineering, and half of that lecture will go to your assessment 2. And in requirement engineering, we covered about basically the detailed design, the glimpse of detailed design, plus the prototyping, right? So you'll get it from there. Week 5, we covered about principles of software engineering, like the foundation of software engineering, why it is important, and process model, software process model as capability maturity model, or ISO, which is the goal of a software company, like where the software company wants to go after 5 years or 10 years. There's a dream of a software company to achieve the higher level certification so that they can get more work. That was covered on week 6. And week 7, last week, we covered about detailed architecture and methodology. Plus, we talked about the detailed design, like all the UML diagrams, data flow diagrams, and ERD diagrams, right? all needs to be, all were covered on last week. And some principles of user interface, right, was covered. So those three things, particularly the first two things, the architecture and the detailed component design, should directly go to your assessment 2. So I think mainly week 4 and week 7, you should directly refer to that to prepare the assessment 2. Now this week we'll be covering one very interesting topic, which is design characteristics and software metrics. One of the very popular term in software engineering, it's called software metrics. And in higher studies of in master's level or the higher level of software engineering, research is still going on for software metrics. It is one of the popular domain. The way software process model is one of the research domain that I discussed when I covered week 6, and I showed a research paper. Similarly, in software metrics, a lot of research going on. Even you'll see that today's lecture, there's some research indication how that area is actually progressing. Now, what is software metrics? Is a software metric is a measure of software characteristics that are quantifiable or countable. Now, software metrics are important for many reasons, including measuring software performance. Now, just probably now you can understand that on week 2, we covered about the software metrics, right? And we, I think we went through an empirical studies. What is empirical studies? Like looking at the past studies, 500, 600, or 1,000 studies of projects, previous projects. We come across a graph, right? And we came across one particular graph, which is effort versus quality of the software project, right? And we draw a kind of a non-linear graph. So this is kind of measurement, right, that we try to achieve. So these performance measurement and is required to plan out the work, how many people are needed. Like if we can get a kind of, for example, quality versus effort graph, then we can identify for a particular 90% quality of the project, that amount of man hour needed, and we can allocate resource accordingly, and we can measure the productivity. For example, the breakdown chart of sprint, it's another graph by which actually you can measure out, like, you know, how, what is the progress happening, and how much effort needs to be done to finish that sprint in a appropriate manner in order to complete the project. Now, and many other uses are required. So we'll see some of the thing today. Now, where we are located. So every week when I start the lecture, we always discuss where we are standing, and this is basically a complete software life cycle, right? The software life cycle starts from the meeting, because you are a software engineer. Suppose you went to a stakeholder, and we introduced a hypothetical example of kind of Bunnings. We went to Bunnings to have the meeting, and they are the stakeholder. And you went there, did the research kind of meeting, not research meeting, sorry, requirement analysis phase. Went through all the requirements and tried to identify the requirements, and you identified functional requirement, non-functional requirement, design constraint, and tried to write the report of 6 degrees, right? 6 dimension of detailed requirement analysis. And that 6 dimension of detailed requirement should be the kind of first part of your report in assessment 2 that you have prepared. Okay, and then once the functional requirement, non-functional requirement, design constraint is done, you tried to start the detailed design. And there are 2 steps. There are 2 steps of detailed design. The first step is the higher level, or the high level detailed design, which is actually architecture. So you try to highlight architecture. Now, in general, for the whole system, there is one architecture required. and you can propose like MVC or client server or whatever is suitable you think. You can propose that. For some system, and or if you think it's a freedom, I mean, there is no fixed rule, it's a freedom. If you, it's a freedom, and whatever you can mention, if you can justify well, you are 100% all right. So if you can say that, okay, for the system, there are 10 functional requirements, for seven of them, I need a particular architecture like MVC, and for the remaining 3, I need a particular architecture, for example, event driven or pipe filter. I mean, that's completely all right. Okay, but in order to justify that, try to use some relevant research. And in your research, research means reference, and look at the recent reference. Now, in your recent reference, if you can justify that this type, for similar projects, they used similar type of architecture, if you can find a reference, then your justification is kind of 100% perfect. Or if you can find out a new findings in the recent research that a new type of a variant of a particular architecture has been used, some modification of MVC or some modification of client-server architecture has been introduced. For example, last week we covered a client-server architecture, and then we showed a variant that sometimes a client can be connected to multiple servers, right? So a similar variant, if you can find any research paper, you are most welcome to mention that in the research, in your study, and we will be impressed that you try to find out a new kind of research, right? And try to, even if you use that as your architecture, you feel free to do that, because you are backing up your justification with the proper references, with the recent references, and you can do that. Okay, so this is where we are basically standing, that we finish the high level architecture and the detailed architecture. Sorry, we finish the high level design and the detailed design. So what is detailed design? Detailed design is all the UML diagrams, like use case, sequence diagrams, state diagram. Generally, in a use case, if there are 2 or 3 actors, I mean, for every actor, for example, if there is a kind of doctor in a particular system, doctor and the patient, then for patient, you can easily identify a state diagram. For the doctor, even you can easily identify a state diagram. For the admin people, you can identify state diagram. So for any actor, basically, you can identify state diagram. And sequence diagram, you can identify where you find a particular functional requirement or a set of functional requirement can be explained with steps, like step 1, step 2, step 3, step 4. If it is a sequence of steps, then definitely you need to demonstrate a sequence diagram. Okay, so this is how you should try to utilize the diagram. So it's not a question how many diagrams you need. It's a matter of how you can express your concept well. How you can express your concept well. That's why in the weekly meeting, during the breakout room, for my tutorial students, we go through the detailed design, and for a functional requirement, we ask, okay, what diagrams you have drawn, or what detailed design you have presented, and then we can suggest more. And I just gave you the clue that if any functional requirement requires states, then definitely you need to put a sequence diagram. And in a use case, either you can use draw a use case for the whole system, or sometimes if you can think deeply, for a 2 or 3, for example, 2 or 3 functional requirement, you can draw one use case. For another 2 or 3, you can draw another use case, or for the whole system, another, whatever is more suitable, you can do. But from the use case, you can know that which actors are working, and those actors, those users should have their own state diagram. Okay, this is how actually at least 3 diagrams you can easily manage. Now, in addition to that, you need to do the data flow diagram. Again, the data flow diagram, if you think you can build a data flow diagram for the whole system, you can do that. Or if you can if the system is very big, you can mention multiple data flow diagrams, plus input output sequence in a table that we showed on week 4 and week 7 that you need to present. Decomposition concept, what we introduced on week 7, that is also part of your detailed design, right? And ERD, that definitely I mentioned that ERD is one of the most important major thing. And for ERD basically is the database diagram. That is basically only one example that is generally applicable for a system. However, if your system is very large, you can actually propose multiple ERD if needed, but generally one is sufficient. Okay, so this is the design has been done. Now you, after that, so everything is prepared, and when we make basically the architecture, which is the high level design and the detailed design, as all those diagrams I just mentioned, you basically almost prepared the requirement specification document, right? And on top of it, we know that we have to do the prototyping, right? Prototyping. So the prototyping is basically how does it look like, right? You haven't yet initiated or made the software, but the prototype is in front of you. How does it look like? You just try to mention using a Photoshop or any image creator tool or any mockup tool. I gave all the links, and there are heaps of examples online. You can use any of these, right? But it should be high fidelity, right? High fidelity prototype design. So just practice, I mean, the very realistic look and feel it must have, with all the colors and all the designs. And every, I mean, the main point here is that for every functional requirement, there must be at least one prototype. For every functional requirement, there must be at least one diagram, okay? And for sometimes for a particular functional requirement, there can be multiple diagrams. If, for example, there is a login, then in the login, there is a login frame, there are 2 buttons. If you click one button, what will be the next step? So everything needs to be shown, right? Which is called flow sequence. I think we discussed that last week, okay, on week 7. Okay, so all these prototypes are actually presented, and those are actually within the part of the detailed design basically, and in the part of the requirement specification. So then in your team, in your software team, you have initiated the, if you follow the Scrum software engineering methodology, then probably you have identified or you have decided that you have to follow like 2 or 3 sprint. On each sprint, it is, for example, 2 weeks long, and you allocated people, and you know everyone is aware of that. We discussed that on week 4, right? And repeatedly about the Scrum and how do they basically work. So you identified and you gave the work. So just imagine that it's a 14 days period, and for the first 3 requirement, your programmer will produce the code, produce the output, right? Suppose there are 10 requirements. On first sprint, you have to accomplish 4 functional requirements and make the software. So your programmer, the team of programmer actually prepared the code, and they actually, their guidance, their guide is basically your specification document, in which all the diagrams and all the detailed designs are presented. So they look at it and convert it to the architecture as well, and they convert it to the program, right? And last week I showed that if there is a client server model, what should be the code pattern. So every help is there, right? And they just convert the program. Now after 10 days, they are prepared with the program. Okay, they are prepared with the program, and today's lecture starts from that point of time. Okay, so they presented the program, and then what feedback you can give. Okay. And the first thing regarding the program or the flowchart and program are kind of, you can say anonymous. So you can, if that program or the flowchart is good and fulfill all the some of the characteristics that will come very soon, then we can tell that the overall design is a good design. Okay, so the definition of good design I'm introducing right now. The definition of good design is few. Actually, we'll identify 4 definitions throughout the lecture. Okay, and this particular slide in front of you will identify 2 definitions, and these 2 definitions are linked with, basically not with the program but with the requirement specification document. Okay, so now we are starting our judgment. So I think you are now 100% sure that where we are standing, right? Your programmer prepared the code and then you're trying to give the feedback, or your your team prepared the requirement specification document. Then also you can demonstrate, you can actually do some testing to give a certificate, or to give a kind of to prove that it is a good design. Okay, so in 2 ways you can basically, so the first characteristics of good designs, that it must be complete. So when you prepare the requirement specification document, it must be completed, which means that if there are 10 functional requirements in your detailed design and architecture, all those 10 functional requirements must be fulfilled, must be accomplished. Nothing should be missed out. Okay, and when all parts of the design are carried to completion, you can say that it is complete. Okay, so the first characteristic, which is mentioned here, basically completeness. Now the second characteristics of good design, so when it is complete, you find that, that's why I always tell you that when you draw a prototype diagram or when you draw a UML diagram, you always mention in that caption that this diagram correspond to that particular functional requirement. This diagram corresponds to functional requirement 2. This diagram corresponds to functional requirement 3. And at the end, you can make a table, which is the kind of traceability report. I think we talked about that once. Traceability report, in which actually you need to mention that, okay, all your 10 functional requirement and which diagram is covering that particular functional requirement, and which detailed design covering, which prototype figure is covering. So if you have that table, then everyone will have the clear understanding that all your functional requirements are covered with all the prototypes and all the detailed UML diagrams and database diagrams or others. Any question? Do you have any question or any clarification needed?
Okay.
All good, right? Okay, so yes. Do you want to ask anything? Okay.
So we need to show completeness and consistency for now. We need to show that in our data flow diagram, right? Because that will represent how much we elaborate it.
Well, again, I mentioned that not only data flow diagram is part of that. For every functional requirement, like if there are 10 functional requirement, for every functional requirement, you need to discuss, right? You need to discuss. How to discuss? It depends on how did you write your functional requirement. Okay, if your functional requirement can be explained in using a use case, a sequence diagram, and a database plus a data flow diagram, then you need to put all 4 diagrams for that particular functional requirement. Okay, so it depends on how you characterized your functional requirement. But my point is, at least 1 diagram is required to demonstrate your functional requirements or group of or set of functional requirement. Now, does it make sense?
Yes.
Okay, so nothing should be missed out. But sometimes it can happen that a group of function requirement may need only one diagram. It can happen. That's why in the meeting you should consult with your tutor that ask for the feedback if you're not sure that for that function requirement, which diagrams are required and how to go with that. That's a kind of good feedback, and it's a matter of group meeting as well. You should try to identify. That's why I gave you the UML website, right? And there are a lot of websites available. So if you look at the diagrams and look at the multiple examples, you'll have the clear understanding, right? How you can apply that in the similar situation. But keep in mind that if you think that you're writing a professional report for a company, because I work in industry and we fight for that, like we write interesting report to get the work. So if you mind that based on your report you'll get the work, then you try to put most of the diagrams. I mean, you should try to put your most effort to make the report kind of detailed and wonderful. Okay, now completeness is simple thing that I just mentioned, that all your kind of functional requirement and non-functional requirement needs to be discussed, has been covered. Now the second is the consistency. Now for consistency, I actually presented next slides. So the first consistency principle, just few consistency principles I just discussed, that's it, which is common UI. So in front of you, if you see the picture, this is a picture of what? This is a picture of a prototype. Am I right?
Yes.
Okay, it's a prototype. Now, again, I mean, some students asked me about the examples of prototype, but this is a clear picture. Now, in prototype examples, my suggestion would be you can either show the prototype for the mobile interface or for the desktop interface, right? It's up to you. Or if you show both, that's fine. Okay, I mean, it's not a big deal. For anything, any platform, you can decide your prototype. That's completely all right. Okay, now just try to give a kind of illustration of completeness here. Suppose your project is about building a website, and it's a responsive website. So responsive website means it should run on mobile, and this is a perfect example of a app. Okay, mainly it is an app, and in this app, sometimes nowadays actually most of the apps are actually pulling data from the website. They are kind of mostly related nowadays, almost kind of anonymous used. Okay, now one of the functional requirement is that in your project there must be a photo gallery of it's probably a website of a company, there must be, or app of a company, so there must be a photo gallery. And if you see this particular diagram, if you look at my mouse, then it is what? It is a photo gallery. Am I right? Okay, it's just I need to hear yes.
Yes.
Okay.
Yep.
So it's a photo gallery. Now why I'm saying that, because in your report you have to do the similar thing. So suppose in your list that requirement 3, just keep in mind requirement 3 is photo gallery. So for every requirement you should put a number. Keep in mind, for every functional requirement, when you highlight the functional requirement, non-functional requirement, you should definitely put a number 1, 2, 3 and the description, right? That you can say that number 3 functional requirement number 3 is photo gallery. You can put a title. Title is better actually. Title, photo gallery, then colon, then you can explain that need to show all the project and all the pictures in the photo gallery. Okay, this is the functional requirement. Okay, so again I'm repeating, every functional requirement you should put a number, you should put a title, and you should put a short description. Okay, 3 things. You should put a number, you should put a title, you should put a short description. Okay, any confusion you can ask me. Okay, all clear, right? So these 3 things you need to mention.
Can you please repeat that? Repeat your statement just now.
For the functional requirement, non-functional requirement, every time you need to mention the number, like 1, 2, 3, 4, right? If there are 4 functional requirements, there must be 1, 2, 3, 4 points. For every point, you need to put a title of that particular function requirement.
Just like here, photo gallery.
Photo gallery, correct. It's completely up to you, and then a description. Make
Need
sense?
to show all the pictures of project or organization or
Whatever, yeah, like the photo gallery, then that this function requirement, or we need to demonstrate, or this portion demonstrates the projects, pictures of all the photo galleries, and some quick short descriptions. Okay, whatever is most suitable, and you need to refine that as well in terms of language. Okay, so 3 things must be there, right? Now, when you draw, so it's okay, Abdul Rahman. I mean, your answer is
yes, sir. Thank you.
okay. Okay, now suppose in your function requirement there is a third function requirement is photo gallery, in which you demonstrated. So when you, my point being, when you draw this kind of prototype diagram, you should put the caption figure that it refers to, that this prototype refers to functional requirement 3 in bracket photo gallery. That's it. So then we are certain that this covers the function requirement 3. So for every diagram, in the caption, you must mention it is referring to which particular function requirement. All clear?
Yes.
Okay.
Is that for each diagram or for each prototype, like each screen?
Okay. Sometimes it cannot be separate. For example, one function requirement shows that the group of things must be done. For example, these 3 diagrams are for a single function requirement. Then what you should do, you should put these 3 diagrams under one figure. Does it make sense? You should put these 3 diagrams under one figure, one kind of caption, under one caption, in which you should mention that those 3 diagrams, those diagrams, or these sequence of diagrams corresponds to function requirement number 2. So my point is, I mean, a group of diagram can be under one function requirement, or a single diagram can be under one function requirement. Now it's clear? Because you cannot find out any other situation rather than that. Does it make sense?
Yeah, it's all good. It's just confused when you say diagram and then you point out to the screen.
Okay, no, now it's okay, right? So you can mention, you can do that. Sometimes it can happen, sometimes that one particular diagram, if you think that it is under multiple function requirement, then you just mention that. Like if you think that these diagrams are under 2 function requirement, then you can mention that this cover requirement 2 and 3. Okay, so whatever situation, you just put it. What my point is that for every function requirement, there must be at least one diagram. Now I think it's clear.
Sir, how many points we should describe?
Sorry?
How many points we should describe in functional requirements?
How many points?
Yes, sir.
What do you mean by that?
Likewise, the functional requirements are described as below 1, 2, 3, 4, 5,
No,
6,
these are not
7.
function requirements. These are diagrams. These are prototype. These are prototype. These are not function requirement. Do you know the difference between function requirement and prototype? Okay, why are you muted? Can you answer?
Yes, sorry. Prototype is like case diagram and user interface.
No. This is prototype is this thing that in front of it is not use case or something. It is just diagram. How does the software look like? Function requirement is different thing. Function requirement at the beginning, you identify 4, 5, or 6 function requirement. What the program is doing. This is function requirement, right? And you, for example, a program is okay. I mean, in your project, monitoring a project, this is probably one kind of function requirement. Or what if you dissect your project, I don't want to repeat that thing. We discussed for the last 7 weeks about all this thing, right? So I don't want to repeat what is function requirement is. Okay, Prashant, can you give can you tell me what is function requirement? Anyone?
Like what system needs to do?
Oh, sorry.
Yes, go on quickly.
It's the actual requirement of that case, like what they are asking for.
Yeah, what they're asking for. I mean, what the project will be doing, right? So you just try to
Yes.
dissect the functionality or task. And if you dissect it into 5 parts, then the project is doing 5 things, right? 5 separate things. So for 5 separate things, you should put 1 point each. I mean, point 1, 2, 3, 4. This is simply point. And for every function requirement, you just give a title, the name of kind of that. For example, one title can be monitoring, right? Monitoring, for example, project monitoring. Another title can be, I don't know, I mean, what's your project? For example, if it is a kind of hospital management system, then one can be kind of patient support is one function requirement, right? You can put a title, patient support, and then you describe the thing. So I think you already did the assessment 1. So this question should not arrive, right? And some of the specific question you can ask during the tutorial time. Now, here, actually, I just mentioned that everything. Now, actually, I didn't cover to the main point yet. The common UI saying, and that is actually required for your prototyping, is that all your interface must have common header. If you look at the header is common, am I right?
Yes.
And the footer and the layout is also common. So if you have all the kind of commonality, and if suddenly one of the diagram is completely out of sync of others, completely different, then probably it is slightly violating the principle of good design. So when you have all the common UI, you are maintaining the good design principle. Does it make sense?
Yes.
Okay, so this is what I'm talking about. So we are actually discussing about the good design. So when you have the requirement specification document, in the requirement specification, you have that prototyping. Am I right?
Yes.
Okay.
Yes.
So looking at the prototype, you can give the feedback that it is capturing the good design principle or not. So one principle of good design is that you have the common UI. When you have the common UI, you are basically maintaining the consistency. Okay. So 2 things we are trying to follow. One is the completeness, another is the consistency. And one component of consistency is common UI. Okay. Second principle of consistency is that all design carried to the same depth level. Okay, again, I'm repeating, all design carried to the same depth level. Now, in a website, in a web project, you basically, mostly you use a contact form, right? Okay, so
Yes,
look
sir.
at that. Sorry?
No, I was just saying yes, sir.
Okay, so this contact form, look at the left side. It is an example of contact form. So in this particular left side contact form, people can use their name, email address, and a question, and then click the send button, and the email goes. Now, what is depth level? The depth level of the left side is basically 1, which means that they don't go to the next step. Am I right? They just fill up everything, click the send button, and it goes. So just one step, a single step kind of contact form. It is not multi-step. Does it make sense?
Yep.
Okay.
Yeah.
And sometimes on the right side, I think you have also came across, I mean, this type of thing, that there are multi-step contact form. Sometimes it is used that in there is some button, name, address, everything of your personal details. You just put everything, and there is a next button. If you click the next button, it comes to the company information, and then you put again all the information. Then there is another next button. If you click it, it asks for the billing information. like the credit card information or other things, then finally the submit button is there. So here the submit button or the send message is at the front, but here is not at the front. You have to fill up all the next step. So this is called multi-step contact form. I'm just giving an example so that you never forget what does it mean. Now, if any, in general, if any website or a project use single step contact form, they need to use the same design across the board everywhere. On the other hand, if any project uses multi-step contact form, they need to use the same contact form in other places of the website. Does it make sense?
Yep.
Okay, in general, okay. Then actually the normal users or the browser, I mean the viewers will not be distracted. They will not be confused. Okay, they will know that, oh no, same level. So this same depth level, I just gave an example that all design carried to the same depth level. Similarly, in the help form, sometimes I think you have come across that in some websites, for example, Visual Studio, there is a help button. So if you click the help button, it comes in front of you, a big kind of index comes in, right? And in the index, you have to search which help you want to go. Sometimes they make it very complicated. There are some question, you can go depth, you can go to the next step, you can search, try to search. Sometimes the help is very simple. If you search, then automatically one answer comes up. I mean, there are no kind of multi-depth level thing. So what I'm trying to, the point is that any design in terms of contact form, in terms of help, even in terms of error processing, sometimes, in your software, if any error comes in, error message comes in, even that error message can have multiple depth. Like next, you can find out what exactly is happening and so on. And sometimes there's no next on a single depth level, all the answers are presented. So whatever point is, if you want to maintain consistency, then you should maintain a single depth level across the border, across everywhere. So if you use single depth level like this left side diagrams, then you have to use the same across the board. If you use multi-step, then you need to maintain across the board. And when you keep that consistency, it means that your detailed design is a good design. All clear? Any question?
All good, sir.
Okay, now we finished the two things basically. Okay, I told you at the beginning that we'll cover 4 things. We finished 2. 2 means that, and the whole lecture is about the good design. Okay, so the whole lecture is good design. So in good design, we covered completeness and consistency. Now the third thing will be starting for good design. The third thing is actually complexity. What is complexity? Complexity cannot be a good design, right? Actually, the complexity means low complexity. So if we can achieve low complexity of the program, it is a good design. Okay, now we'll come to that point. So to calculate complexity, this portion, so the previous 2 portion, like the consistency, so these 2 things basically, the consistency and the completeness, these 2 things, this slide is focusing on your diagrams. Am I right? Your detailed diagrams, all the UML diagrams, all the prototypes and everything. Okay, they are covering that. And these next 2 diagrams, next 2 steps that will be covering, this is the third one, and next the 4th one will come. This one is actually looking at the software code, the source code that your programmer has developed in the 10 days, in the first sprint, right? So what it is doing, it is calculating the complexity of your software code. Again, I'm repeating, this particular thing of complexity, we are now, where we are standing, we need to know, right? We are basically right now calculating the complexity of the software code that is presented to you by your programmer. Does it make sense? Any question? Okay. What is then the complexity? So complexity basically is a number. So somehow we have to measure that a code has been presented. Suppose a sorting code has been presented to you. Your developer has prepared a program, a function of sorting algorithm, okay? And then he presented you the code. Now, you or he, I mean, both of you can actually calculate the complexity of the code by looking at the code. It can be Java code, it can be C code, right? Looking at the code, you can actually draw a kind of flow chart. I think you have, all of you have done a programming course in which you know how a flow chart has been done. I'll show the picture, but you know, step one, step two, you can put a you know, the rectangle, then if condition as a diamond symbol, right? And you put a arrow sign to go to the which step you want to go forward, and on the right side, left side, on different condition, right? That you have definitely went through. Anyone didn't go through flowchart? Is there anyone? Okay, I think everyone went through the flowchart. So looking at the flowchart or looking at the code, both are actually kind of synonymous thing. I mean, same thing. So looking at that, you can identify, or you can follow these 4 particular technique. There are 4 particular separate technique. So using any of the technique, they actually do in a different way. So using those technique, actually you can tell that the complexity of this particular code is 3, or the complexity of this particular code is 5. Okay, now why you are doing it? Suppose you have 2 kind of program written for the sorting. There are 2 sorting algorithm or written as a code. Now, if you do any of the calculation on that particular code, and how to do that calculation, I'll show that. It is very simple. I'll show that in the next slide. Then for the first code, you have identified that the complexity is 5. And for the next code, second code, the complexity equal to 7. Now, which one is less complex? The 5 one, am I right?
Yep.
Okay, so we have to take the 5 one, or if we have opportunity, we can reduce it more. Okay, so we can calculate the complexity of the code using some numeric figure, some calculation of all these 4. I'll go through that, and by which actually you can identify the complexity level of your program, and we can take further decision, can we improve it better? And the proof of improvement, if I say that, okay, I can improve it, and I did that, I just modified the code, then again, you need to calculate the complexity. And then again, you need to complete the calculation. If you find the number went down, then you can say confidently that, okay, yes, it is now less complex, and we should proceed with that. Because if it is a less complex program, it should run faster. It is doing the same job, you know, in a faster way. So that's why we should go for that less complex one. So if we can achieve less complex program, we are actually achieving good design. Okay, now there are 4 ways by which actually we can calculate the complexity. 2 of them look at the code style, and 2 of them doesn't look at the code style. Okay, I'll come to that point. So out of these 4, there are 2 types of strategy. One, I say white box technique, another is a black box testing. White box means you look at inside the code to calculate the complexity. Another is you don't look at inside the code, but you do some other measurement to approximate the complexity of the code. Okay, we'll come to that point. Okay, the first technique is called Halstead matrix. Okay, suppose in your code, what is the major component of your code? If you look at your code, for example, you see there is a code I've written C equal to A plus B. Okay, now you can write many things inside the code, right? C equal to A plus B, then next line equal to D equal to, you know, 2C plus A plus B. You know, you can do a lot of calculations, and all these are in a single function. Just so basically, Halstead is one of the scientists. He proposed that in the program, in your function, and everything is covering the function. I'm calculating the complexity of a single function. You always think in this way. I'm calculating the complexity of a single function, and all these lectures we're covering is kind of very, very relevant if you get a job in a software company. Then you will see that you will always calculate that and try to optimize that. Okay, so in any program, any function, we may mainly come across with two things. One is operand and second is operator, right? So look at that, this code. Can you tell me which are the operators? Is there any operator in this program? Like in this line?
The CAB.
No, these are the variable. Operator, I'm talking about operator. Operator is the plus sign.
That's the plus sign.
Plus sign and the equal sign. Because you add it and put it into the C, right? How many operators are there? Two. Plus and equal, okay. And how many operands are there? Three. C, A, and B, three, right? So these numbers are important. So again, conclusion is how many operators are there? Two. And how many operands are there? Three. Okay, so look at here. So this helps it only calculate the number of operator and operands. And based on the number of operator and operands, it just calculate the effort of the program. Like effort means what? Man hour, am I right? Like how many people required for how many hours for the project, for the writing that function. All clear?
Yes, sir.
Okay, so look at that. N1 is a number of distinct operator. N2 is the number of distinct operands. N1 is the sum of all N1, which is the number of all distinct operators, and N2 is the sum of all operands. Now, program vocabulary is N1 plus N2, is small N1, which is the distinct one, and program length equal to total number of operand and operator. Now, he calculated four metrics. Volume, program volume equal to V into N times log to N, and potential volume equal to V at equal to 2 plus N2 at log to N plus N2 at, based on the most succinct programs in N2, the most recent version of the N2. And program implementation level equal to V at by V, and effort equal to E equal to V by L. So this effort is the main thing. You can measure how much effort you need, and based on that effort, you can, this effort is actually proportionate to the complexity. Am I right? So if the effort is high, complexity is also high. If the effort is low, complexity is of the low. So if you have two versions of the code, if one effort is 30, another effort is 20, which one is less complex? The 21, am I right?
Yes, sir.
Simple. You got it? So, and now suppose your program developed a code as a software engineer, just think about the real life. You presented it, then if you can, from your experience or from the group meeting, from the other programmers engagement, if you can find out that we can improve the code, we can reduce some of the operator, and if you find that your effort, this effort calculation has been reduced, which means your complexity has been reduced, then you can go for that. If it can do the same job, if that function can do the same job. Okay, I think Halstead matrix is clear right now. Okay, any question? You need to actually understand the basic, the idea of that thing, and that's the most important thing, not the calculations or other things. Is it okay? So you're basically looking at the source code, number of operator and operand, and trying to identify what is your effort and what is the complexity of the program. Now, these logic, this program, do you have any question? Just all good? Yes or no? Or just ask me if you have any question.
No, all good.
All good? Okay, now, one thing is missed out here. In the program, there are some if condition or logic, while loop, if condition, right? If else condition, statement. So if else statement is not covered by using the operand and operator. Am I right? Are you following?
Yes, sir.
Yes.
Okay, now we do you want to say anything, Taike? I mean,
No. I just say yes.
okay, so we need to consider another thing. That's why another next step will come. So this next step is called cyclomatic complexity, and this is the most important popular technique for programming, for calculating complexity. Okay, in most companies they actually follow only this thing. Okay, cyclomatic complexity. We in real life we basically look at the cyclomatic complexity. Now it covers all. It covers operand operator plus the if condition and the logic, because logic, if condition, while loop, the loop statement, these are the major construct of the programming, right, on the function. So it actually covers that. Now I would explain cyclomatic complexity in a very simple way, and that you will never forget basically. Now this is the diagram in front of you is nothing but a flowchart. Am I right?
Yep.
Yes, sir.
Okay, so it's a statement. If it is a if condition, am I right? It's a condition. So if the condition like E2 is true, it goes here. If E3 is true, it goes here. You don't know what is E2, E3. It doesn't matter. It is just a statement, right? So again, it's the if condition. If E5 is true, go here. If E4 is true, go here. Execute some statement and go here. So this execution is called node. It's called node, right? N-O-D-E. And this line is called age. So nodes and ages, these two terms are there, and these two terms we know that in the flowchart it is very common, right? Okay, now the formula of the complexity of this code equal to E minus n plus 2p, and this p is always 1 because it is a one single function. So p equal to 1, so it becomes 2. E equal to number of ages. Now how many ages there? 7. E7, total E7. And how many now nodes are there? 6. Total 6 nodes are there. So if you put those numbers, it becomes 3. Any question by anyone? All good?
All good.
Okay, now I'll show you a easier approach to calculate that. You don't need to look at all how many nodes and ages. You just look at that how many loops are there, how many internal circles are there. Okay, you see that there is one region, one loop, like this thing. It is a closed region, one closed region. Am I right? One circle. Any confusion by anyone or all good? This is one region, and this is the second region or second closed region. So the term is, it's called closed region. Closed region. How many closed regions are there? Can anyone tell me? 2. Am I right?
Yes, sir.
2. So the answer is 2 plus 1 equal to 3. Okay, so number of closed region plus 1 equal to 3. So you don't need to look at all the number of nodes. Just look at the how many closed region, and the answer is equal to 3. Okay, so the cyclomatic complexity or McCabe cyclomatic complexity of this particular function is actually 3. Okay, now another example. It's a particular switch statement, and the flowchart has been drawn. So what is the, how many number of connected regions are there? Can you calculate? So this is 1, this is 2, this is 3, and this is 4. Am I right?
Yes.
4. So 4 plus 1 equal to 5. Even calculating node and age, you can get the same number. Okay, so if you have, if for example 2 codes are presented to you, one is this and one is this, and if they're doing the same job, same functionality, which one is more efficient? What do you think? This one, am I right? This is 3 and this is 5, so we have to take the 3 one. So now everything is becoming clear, right? Where we are heading off. I mean, you are actually giving suggestion to the programmer how to optimize his code. Am I right? I'm just going very slowly so that you can never forget this thing. Do you have any confusion or any question?
Can you please repeat the previous one more time?
Okay.
So, no, not this one.
This
The
one,
next.
right?
Yes.
So in terms of calculation, I mean, for any flowchart, you need to identify the number of closed region. So this is one closed loop, right? It's one loop, one. This is two. This is three. And this is four. Am I right?
Yes, sir.
So what is the complexity then? 4 plus 1 equal to 5. So anything plus 1. Now clear?
Yes, sir.
Okay.
So we are
now
comparing this one with the previous one.
how did I compare? That was your question, right? So for example, you have written one programmer, suppose you have written a code like this. Okay. And the
Okay.
complexity is 5. Now you can, and this is doing a sorting algorithm, just for argument's sake. It is doing a sorting algorithm, sorting. Now, if you modify the code and if you come across the same thing, and it is also doing the same sorting, but you find that this particular code's complexity equal to 3. So which one is less complex?
This one.
This one. So definitely go for that.
Okay, thank you.
Okay, so for any code, you just looking at a code, try to reduce the complexity, and that is your suggestion. That is your feedback as a software engineer to your developer. Okay, all clear, right? So these two complexity, what is the difference? Can anyone tell me? Halstead and cyclomatic complexity, what is the difference? Can anyone tell me quickly? Let's see. What is the main difference? So this one is considering operand and operator, and this one is considering the if conditions, right? I need a response. I mean,
Yep.
So,
okay, same thing. So both of them, Halstead and cyclomatic complexity, both of them are actually looking inside the code. Am I right?
Yeah.
They're looking inside the code. Okay, after that, I'll give a break. We need a break, basically. Okay, now, two more things very quickly I'll go through. You don't need to worry. Now, the next technique is they don't look inside the code. Okay, so Henry Kafura method, again, it is calculating the complexity, but in a different way. Now, suppose this is a module. What is module? A function, right? A function or procedure. So for this module, there is some inside code. I'm trying to calculate the complexity of the code. Now, you know that any module is basically connected to another module, because a module cannot be separate. Any function must be connected to another function, right? And those functions are connected by what? Those two functions are connected by parameter passing, global variable access, input and output. So one output of a function goes to another input. Am I right? So this is how they're connected. So we try to identify how many variables are connected between them, how they communicate, and using those numbers, we are trying to calculate the complexity of the module. So look at the diagram, look at the figure. In a module, there are 3 input parameters are coming in, and these 3 input parameters are called fan in. So fan in equal to number of intermodular flow into a program. So intermodular flow is all these things: parameter, global variable access, parameter passing, and so on, input output. And fan out, number of intermodular flow out of a program. So from this module, it is actually going to another module, right? So only 1 is going out. 3 is coming in, 1 is going out. These 3 are coming from other modules, and this 1 is going to another module, right? So for this particular module, fan in equal to 3 and fan out equal to 1. So the complexity formula is fan in times fan out whole square. So put 3 into 1 whole square to 9. So therefore, the complexity of this module equal to 9. All good? Do you have any question?
all good.
Okay, simple thing, right? So it is kind of, don't look at inside the code, how many parameters coming, how many parameters going. Based on that, you just do the calculation. You just do the approximate thing. So if you find 2 modules, one module has kind of complexity 9, another module has complexity 6. So the 9 one is more complex, right? Okay. Second, the last technique is called card and glass method. Again, card and glass method exactly similar to the Henry Kafura. So it only looks at in and out, fan in and fan out. Don't look inside the code. So it actually introduced a few more concepts. Structural complexity equal to fan out whole square. And we know what is fan out. Data complexity equal to px divided by fan out plus 1. Px equal to number of variable passed to and from the module. And system complexity equal to sx plus dx. Whatever value we get, we are getting it. So basically, this card and glass method is nothing but that fan in and fan out calculations. Am I right? All good, right? This fourth thing. Now, just one thing I'll just give the break, which is for the first two method, Halstead and cyclomatic number, I'm looking inside the code. Am I right?
Yes.
Okay. That's why you can say it is a white box type of complexity measurement. Am I right? White box means you are looking inside the code. All good?
Yep.
White box, right? Now, the other two, Henry Kafura and card glass, we are not looking inside the module. We are just looking outside. So outside tracing, how many inputs are coming, outputs are going. That's why it is called black box. We are not looking inside the box. Am I right? It's a kind of black box approach. The first two is white box approach. The last two is black box approach. And this white box and black box are basically used in software testing as well. That's why I just introduced that concept. Okay. So did you get the clear picture of complexity?
Yep.
All good, right? Okay. So I'll be back in 3 minutes time. Okay, so so far, how did you find the contents regarding good design? Was it interesting? I just want some feedback from you. Anyone?
Yes, sir, it was interesting.
Kind of.
Little
Okay.
bit, yeah, interesting, sir.
Difficult or hard or easy?
Yeah, a
What?
bit difficult for the first time, yeah, but
But
still
it should be
interesting.
okay. But at least,
Yeah.
I mean, you don't need to know everything. I mean, all the details, all the equations, you know, you don't need to go through, but at least the basic understanding, and at least as a software engineer, if you know that where you are standing and how to manage the people based on what, then actually it will be useful. You got it? And
Yes, sir.
sometimes, for example, even the calculation, for example, the cyclomatic complexity, you should advise your programmer to give you the number of cyclomatic complexity, and then you can discuss with your team, how can we, you know, lower the cyclomatic complexity number? How can we modify the code so that the complexity number goes down? This is how you know, the teamwork happens. But at least you need to know the basis, the basic ideas, that what's going on and how to optimize the code, right? So it's a teamwork, so it happens in this way. Okay, so far actually our main topic of discussion is good design, am I right? So what we have learned: first, consistency, then completeness, right? Remember, completeness is all the requirements have been completed. Consistency, like common user interface and all these things, and same depth level. And then the third good design principle was calculating the complexity. And to calculate the complexity, we came across 4 different types of techniques, right? 2 of them are looking inside the code, and 2 of them looking outside the code, and fan in, fan out things. And we calculated it. Okay, now one of the most important part will start. That's why I just gave a break, so that you can be fresh and you can start. And this is one of the most important topic, I would say, of today's. So our basic idea of good design is basically the design, the code should be easy to understand. It can be changed, it can be reused, it can be tested, it can be integrated, it can be coded in a nice way. Okay, and to achieve all the easy thing, we need to get to last thing, which is cohesion and coupling. Okay, these 2 new term, it is very new for you, cohesion and coupling. Okay, but the idea is not that difficult. It's easy. Basically, I'll try to make it as much easy as possible. That's why I modified the slides, put more code, very simple code to demonstrate the thing. Okay, so just try to concentrate, and it's easy. You'll understand that. And this is the main essence of today's thing, and I would say take away from today's lecture. If you understand that, I would be happy that you understood the most important thing, because this is more practical in professional area. Plus, for higher study research, cohesion coupling is one of the promising field. Always, it is always, you know, a research challenge. Okay, now what is cohesion? What is cohesion? I just read it first. Cohesion of a unit or a module. Always think about anything we are discussing, like the previous example of calculating complexity is only about one module, am I right? Or one function, right?
Yes, sir. Yeah.
Okay, so only one function. Okay, now that one function, what can happen is that addresses the attribute of degree of relatedness within the unit, module, object, or component. So a new term has been introduced, which is called degree of relatedness. What is this degree of relatedness? Okay, I just give an example. Suppose you have written a function, in which you are doing 3 things. Just try to think 3 things. 1, you are doing the network operation, like reading data from the modem, sending data from the modem. That is one function. Second, you did the graphical user interface function, you know, all the GUI development, the swing object making, like the graphical user interface. And third, you are doing the database operation. So how many operations you are doing? 3 operations: network operation, network functionality, Then second is the graphical user interface functionality, which is the just drawing, right? Drawing type of function. And third is the database function. So your code is probably 100 lines. First 30 lines is actually network operation. So it is one function. So in one function, first 30 lines is basically the network operation. Next 30 lines is the database, graphical user interface operation, and remaining 40 lines is database application. Now, my question to you, all these three functions are related or unrelated? What do you think? Are they related? Actually, the answer is they're completely unrelated. Am I right? Like they're completely different thing. One is database operation, another is network operation, another is graphical user facing on operation, like the design operation, design thing. Design means prototype, like the GUI development. Do you agree?
Yes, sir.
Completely separate thing. Now, if you put all these three separate things under a single function, what is the degree of relatedness? Okay, now coming to that point. The degree of relatedness is very low of that particular function. Do you agree? Because all these three are separate functions in a single file. So their degree of relatedness, so degree of relatedness is basically one number. By looking at how many different types of programs are inside a single function, you can say that the degree of relatedness of that particular function is very low. Does it make sense? Or do I need to repeat?
All good.
All good, right? So this is, so in that particular condition, particular situation, what you'd like to do? Can you give any idea?
Separate these three.
Simple. You just separate it. You just separate it, right? You just separate all these into kind of a separate class or separate function, right? Okay, now there's a point that if everything is in the same location, that is called coincidental. Look at the diagram. Now I'm trying to relate it everything. Coincidental. And this is the worst. Am I right? Are you following? Yeah. And then if you separate everything, it becomes something different. Okay, now the point is, can you make 100% separate them out? I mean, is it possible at all? What do you think? Actually, what happens is that you can make separate, that's fine. Database in one function, network in one function, GUI in one function, but from the main function, you're actually calling everything. You're actually calling every function from the main function, because at that particular point, you need to integrate all together. Am I right?
Yep.
Yes, sir, totally.
So for the main functions, degree of relatedness is actually low. But for the individual functions, degree of relatedness is basically very high. Are you following?
Yep.
So, however, if you do the average, the overall degree of relatedness is very kind of high, right? Because main is just only one function, main function, right? So the point being that if you can make 100% kind of separate, all the functions are 100% separate, then that becomes basically functional thing. Okay, so if every function in a single function, that is called coincidental, and if all the functions are completely separate, is actually functional. But in real life, actually 100% functional you cannot achieve, because there must be a point like main function where you need to join everything. Otherwise the program will not run. If all these are separate, if you don't connect plugin in one particular function, the program will never run. So the functional is ideally desirable, ideally we want to achieve, but you cannot actually go to that point. You can go 90% close to the functional or 80% close to the functional. Are you getting my point?
Yes, sir. Yeah.
Even sometimes the network and database, for example, those functions have some connectivity, because everything cannot be completely separate. For example, in a graphical user interface always draw the graph based on how much data is coming in the network. So sometimes, occasionally, they have some connectivity. So they cannot be 100% separate, always kind of completely separate it out. Then actually the program will never basically run. But our objective is to make them separate as much as possible if they're not related. Am I right? Okay. Now we'll actually look at the intermediate positions, situations. Okay, slowly. Okay, the first step is logical cohesion. So we were actually in coincidental, where everything was together, and look at the next step is logical. So logical, suppose in your program there is a print all command. So a print all procedure. If you click the print all procedure, what happens is that, suppose this is the Bunnings store. So if you click the print all, it print a local sales report. So local means from that branch, if you click in a particular suburb, on that suburb report has been printed. Also a regional sales report has been printed, a national sales report is printed. Now try to think, in the regional sales report, the local sales report is also included. Am I right? And in the national sales report, the regional sales report is also included. But what is the difference? In the regional sales report, the local sales report is included plus additional reports are included. In national sales report, the regional sales report is included plus additional regional reports are included. So in other words, the portion which is common is the related portion, but the other portion is the new portion. Am I right? Are you following?
Yep.
So it is a subset, right? It is a subset of this set. It is a subset of this set. So whenever any function works in this way, that is called logical cohesion. So in this particular program, some portions are common, they're doing related work, but some portions are not related. Okay, so it is not 100% unrelated or 100% related. It's a mixture, some mixture. Okay, so it is a slight improvement. Okay, second is temporal cohesion. Okay, to discuss temporal cohesion, okay, who knows about constructor function in Java? Who knows that? Can anyone tell me what is constructor function in Java? Anyone?
That's the function to create class.
Okay.
Object.
Very good. So when you create an object, that function will be always executed. Am I right?
Yep.
Okay. So otherwise that function will never be executed. And that function will be executed only once when the object is created. Am I right? Are you following?
Yep.
Okay, so that's it. But a class, okay, I'm repeating, a class can have actually three functions. One of the function is the constructor, which is the name of that function of the class name, right? If the class name is my world, the constructor is also my world. Same kind of thing. So my world will be executed when I make the object of that particular class. So once the object is made, then only you can run the remaining functions anytime. But the constructor you cannot run again. Am I right?
Yeah.
Okay. So what you can do in the constructor, that you can do some initialization process. Suppose before running the program, you need some initialization procedure to open all the file, initialize array and all the variable, and set all the constant. If you want to do any type of initialization procedure, the best thing, you do everything under a constructor. Then initialization process will happen. And this initialization process is called temporal cohesion because it is run a particular time, not always. All good now? Okay. Second, communicational cohesion. Communicational cohesion is that you write a function in which you write a procedure. I'm just using that word procedure because procedure, I'm saying procedure because then under a single procedure, we do multiple function. That's why I use that procedure and function in this way. So under a single procedure, You have done 5 function, 5 tasks. Now, all these tasks on a single data file, on a single data source, or a single array, or a single data structure. For example, the data structure is the transaction file. So what you do, under one procedure, you read the transactions into array. Then second task you do, you sort the transactions, you find the mean or average of the transactions, you print the transactions, you write the transactions. So every function you're doing on a single data source. Am I right?
Yes.
That is called communicational cohesion. And if you write a procedure like that, just think, its degree of relatedness is basically very high, because they're only working on a single data source. So they're actually doing similar or related work. Are you getting my point?
Yes, yes.
Which is good, actually, which is not bad. That we actually want. In a single location, we do similar related type of thing. That is what we want to achieve logically within the function. So I'm probably trying to give an idea that you now know what type of program is good and what type of program is not so good. Like the communicational cohesion is kind of better approach rather than logical cohesion or the other things, or the coincidental, which is the worst, right? Everything into the single place, right? So we are slowly improving actually. Final, next is the sequential cohesion. Okay, sequential cohesion is that, so previous thing, communicational cohesion is on single data file, I did many function, right? And I'm now making it more better. Like in sequential cohesion, you make a procedure in which suppose you are doing 4 functions. Now what happens is that, I'm just reading that, the functions. Search an array for a certain name. Place the name, so whatever you get from the first function, take the input and place the name into another array and sort the array. Then third, change the name from the first to first last. So whatever you're getting, you're doing it. Then finally print the first last name. So what it is happening is that it is just step 1, step 2, step 3, and step 4. So from the first function, whatever output you are getting, it will be put as an input into the next function, and then do the next function. Once it is done, it will be required, the result of this function is used as an input of the third function, and the result of the output of the third function is entered as an input to the fourth function. So the output of this goes to the input of this, the output of this goes to the input of this, output of this goes to input of this. So what do you think? All these 4 functions are basically doing one single big function. Am I right?
Yes.
Yes. So this sequential cohesion's degree of relatedness is the highest. Not highest, is more higher than the previous. All clear?
Yep.
Yep. So, and the final is when you do exactly one function. Sometimes it is not possible, but this is the kind of highest, almost highest level. Okay. Now look at the code, then it will make sense. Is that a pure Java example? I just demonstrated found out that example, and that will make everything very clear. Okay, I can guarantee that. Okay, so look at that. The class, it's a class. There are 2 private variables, and I don't need to explain what is private variables are. What is private variable is used within that class. Okay, there is a method 1. This method 1 is uses both private variable, element 1 and element 2. There is another method 2 that is using again element 1 and element 2. Now just try to think. Suppose this element 1 is a if you can imagine, if this element 1 is anything related to the kind of graphical user interface, then this method 1 and this method 2 is almost doing same or similar job. Am I right? Because they're using the same variables. What I'm saying, if a function uses the same variable of other function, then those functions are almost kind of identical function, or they're doing the similar type of job. For example, This is a calculator program. So this method is doing the addition, and this method is doing the subtraction. So they are similar type of job. Am I right?
Yep.
Okay, simple thing. So if you find that the whole class is basically doing a kind of similar type of job, all the methods, its cohesion is high, and that is actually desired in your program. Now look at the second example. Okay, before going to the second example, do you have any question on that? Any confusion by anyone?
All clear.
Okay. Now low cohesion, just try to think. Suppose there are three variables, element 1, element 2, element 3. Method 1 is uses only element 1. Method 2 is using only element 2. Method 3 is using only element 3. Now, what is element 1? For example, element 1 can be graphics operation, graphics variable. Element 2 is a database variable. Element 3 is a network variable. So these are basically doing three different functions. Am I right? One is doing the GUI, another is doing the network, another is doing the database. And if all these are in the same class, their degree of relatedness is very low, right? So their cohesion is very low. All clear? These two difference?
Yes. So we
Any question or? Now the question is, which one is desirable? Which one is desirable? High or low?
Cohesion,
Sorry?
the one with low cohesion.
Why? Desirable means which one you expect to write in the program.
High cohesion.
High, definitely high. Because in this low cohesion, you are doing different job in a single program. You should never do that. Still confusion is there, Abdur Rahman?
Yeah, a little bit.
Which one is confused? I'm not getting you. So I told at the beginning that you cannot write graphics, everything into the same program. Am I right? Did I tell you?
Oh, sorry. I just
Okay.
got it mixed. Sorry about that.
Okay, now I think you got it. Okay, so now the next question, if you find a low cohesion program, how to fix it? Can anyone give any suggestion? How to fix that low cohesion? What to
Create
do?
another class.
Yes,
and do
very good. So you make three classes. Put method 1 and element 1 into one class, method 2 and element 2 variable into second class, method 3 and element 3 into third class. Then all separate concerns are completely separated out. Does it make sense, all of you? That you basically do, right? Okay, so now all clear. So what we are trying to do is basically we are trying to make separate class or separate functions which will do different job, and everyone is doing only one job, only one type of task, right? Okay, now the next thing is the coupling. So coupling is considering about, couple means what? Two separate thing, right? Two separate thing. We try to make them independent as much as possible. That's called coupling. Okay, that's called high coupling basically. So coupling addresses the attribute of degree of interdependence between the software unit, module, or component. Okay, so what happens is that if we have a graphics operation, a graphics class, one graphics class, one database class, then we try to make them completely independent as much as possible. If they're related, how can they related? So I'm just trying to find it out. Okay, if there are two classes and if we access the internal data or procedural information, they're called content coupling. They're mostly coupled, they're mostly kind of joined. So if they're mostly coupled, then their interdependence is very low, right? We need to make them separate completely. So this is the worst, content coupling, because they're completely related. Common coupling is if there are two units, they refer to the same global variable. If the two units refer uses the same global variable, then they are actually kind of related. That is called common coupling, which is also not desirable. Control coupling is one unit passes control variable to and explicitly influence the logic of another unit. So still one unit is passing a parameter to execute some of the portion of that particular unit. So they are actually related. So they are not completely independent. Are you following, everyone? I'm just going through a bit of quickly. Any question? Okay, stem coupling is passes group of data to another unit. So there are two units, one group of data goes to another. So still they're connected, right? Because when they pass the parameter or data, it is connected. Data coupling, they passes only needed data to another unit. So two units pass the data whenever it is needed. And if nothing happens, two units, they do not pass any data, any information, they are called no coupling. So no coupling is required, but it is practically impossible. So in coupling, we need to go lower value. So lower the better. If we go lower coupling, means they're completely dependent, they're completely kind of independent, then this is the best. Okay. Now look at the example, then it would be completely perfectly all right. So tight coupling, look at the code, everyone, just try to follow the code and you'll understand the code. Is that there is a class volume, there's a class volume void main, and you're calling a cylinder class, and you're putting 3 parameters 15 15 15, and this cylinder class is calculating in the constructor the volume, and it is passing the volume and you're printing it out. So class volume and class cylinder, class volume and class cylinder are bound together and work with each other as a team. Am I right? So if you change anything here, it will be reflected here. Am I right? Did you follow?
Yes.
Because if you change the equation, the result will be changed here, which means this class and this class are completely tight bound. They are completely 100% linked up. They are not separate. So it is called tight coupling, this situation. All good? Feel free to ask question. I mean, if it's not clear, this is a basic Java code. Okay. Now another situation, just try to think, is that there is an interface. I'm not sure whether probably you have used interface in Java, interface food, and it is displaying a function display. Now there is a class Chinese implements the food, and in that actually you just define the display function here, and system out print Chinese, and class Mexican implements the food. So this class is linked to that, and you are modifying the display function and print out Mexican food. So when you create an object of Mexican, this will be printed. When you make an object of Chinese, this Chinese will be printed. So in this above example, so just try to think, what do you think? So this class is uses interface food, this Mexican is uses interface food. Class Chinese and class Mexican, are they related? What do you think? Are they directly linked up? Yes or no? No. Completely separate, and they are connected to the food and they're executing the function. So look at that. In the above example, all two classes are loosely coupled. They are actually loosely coupled because they're completely separated. Okay, and it simply means that you can use the food interface to provide service by injecting appropriate implemented services. Okay, and that's why interface is achieved to implement loose coupling, and loose coupling is desired, right? So can you tell me which one is desirable, tight coupling or loose coupling?
Loose coupling.
Loose coupling, definitely. Loose coupling is most desirable one. If in your program there is no loose coupling, it's a bad. That's why interface is almost, I mean, recommended thing for achieving the loose coupling. Okay, so what is the takeaway from today's lecture is this. So today's lecture, we can conclude that in essence, high cohesion, look at this line is the main summary. High cohesion means keeping parts of a code base that are related to each other in a single place, in a single class. And low coupling at the same time is about separating unrelated parts of the code base as much as possible. Okay, so high cohesion means keeping similar thing into a similar class, and low coupling means unrelated. For example, graphics function, database function, network function, they just keep it as much as possible, as separate as possible. That is called low coupling. Okay, so in cohesion, high cohesion is better, and in coupling, low coupling is better. Okay, so high cohesion and low coupling. Again, remember the formula: high cohesion and low coupling. All good by all of you?
Yeah, good to me.
Okay, that's okay. So high cohesion and low coupling is the fourth good design principle. All makes sense now? So we identify throughout today's lecture, and the last few minutes I'll talk about the user interface basically. So what we have learned so far, just very quick go through. A lot of things we covered actually, basically, right? Is that there are 4 good design principles. I'm just giving a summary. Then if some of you have any confusion, from that summary you can have the clear idea. And if you can understand the summary, that's also good enough for today. There are 4 good design principles. First, it must be completed. So this is the first design principles. Completed means all the diagrams should cover all the functional requirement and non-functional requirement. Consistency is the second good design principle. In consistency, we came across with the common user interface and all design carried to the same depth level. Okay, this is the second thing. So completeness is the first, consistency is the second good design principle. Third good design principle is your complexity should be low. The code complexity should be low. So right now, actually, you are looking at the code, software code, and you are calculating the complexity. If you find the complexity is very high, the question is, can you try hard to lower the complexity? And calculating the complexity, there are 4 techniques. Cyclomatic complexity is the most popular one, and closed region and so on. So by which actually you are finding out the low complexity. So achieving low complexity code is the third good design principle. And the fourth good design principle is cohesion and coupling. And what is the principle? We went through a lot of cohesion and coupling examples, but the final conclusion is, if you can achieve high cohesion and low coupling, your 4th design principles are achieved. Again, I'm giving the summary again. There are 4 good design principles. First, completeness of the requirement. Second, consistency, which is common UI and other things. Third, achieving low complexity code is the third good design principles. And fourth, achieving high cohesion and low coupling code is the 4th design principle. All good now? I think so.
Yep, good to
Okay,
me.
and this
Thank you.
4th thing, just keep in mind, this 4th thing, if you get into any job, all the time in any project as a software engineer, you need to focus on these 4 good design principles all the time. So the first 2 are based on the requirement specification document, like all the diagrams and so on, and whether it is complete or whether it is consistent, and look at the prototype. And the last 2, you have when your programmer give you the program code, then actually you look at the code, you try to make it less complex, you try to put it high cohesion, you try to make it low coupling, and try to optimize the code. So the 4 among the 4 good design principle, the first 2 are covering the requirement specification document, the detailed design, and the last 2 are covering the source code, the program that your programmer is developing, and you're trying to optimize the code, and it is also part of the good design principles. Okay, the one question, I think someone raised hand. Okay, anyone raised hand? Anyone want to ask anything to me? Do you have any question? Okay, I hope everything is now clear, right? Okay, now the final thing is the user interface. Okay, in user interface, I'm not talking about any kind of how user interface is designed. No, that is covered already. And I gave a very fantastic examples of kind of user interface at the beginning of today's lecture, right? Like this, that you can get idea how to make a kind of a prototype as an example. You can do your own way. Okay, now what I'm talking about today is a kind of research oriented discussion. And I would suggest you can use that in your report as well. I'll suggest how. I'll give you actually a kind of advanced optional thing to do in your prototype if you get time in your final report of assessment 2. It's a kind of the good students can try to think how we can do it, because some of the research component need to put. Okay, now many scientists proposed many ideas, principles of user interface. So one is Mendel. Mendel proposed that there are 3 golden rules for user interface design. 1, place the user in control. 2nd, reduce the user memory load. 3rd, consistency. And I think we talked about consistency before, like common UI and other things. 2nd concept came from Schneiderman and Pleasant. 8 rules of design. Okay, this is important. I'll discuss that slowly. So Schneiderman and Pleasant talked about 8 rules of design. For every 8 point, I'll discuss using picture. Okay, the first point is consistency. In your design, it must be consistent across the board. So one of the consistency, we already discussed that the header and footer should be the same. For example, in Mac operating system, you see that in the old Macintosh operating system, the title was at the top. Am I right? Unlike Windows, in Windows, it is always at the bottom. The start button is at the bottom, is not at the top, right? And in the latest version of Mac, it is always at the top. So they actually maintain the consistency. Second point, shortcut. In your program, you should use some shortcut. Shortcuts are really useful for the people who will be using your program in the long run, because they don't always try to, they are familiar with the shortcut. That's why in MS Word, any application, you always see the shortcut there, right? Like Control Command V and Control C, Control V, like copy paste. Those are given. So in your application, try to do the shortcut. If you follow that, you're actually following Schneiderman good user interface principle. 3rd, information feedback. Look at the title, information feedback. For example, when you copy this file into a folder, what do you see? You see a animation. Am I right? You see a movement of the file and it goes there. So this movement is basically an illusion. Am I right? It's an illusion of movement. So giving you the peace of mind that something is copied across. And if you do not drag it, if there is no drag capacity in your program, then probably user will not really understand, will not be 100% confident whether the file is copied or not. Any question? Or all good? Just tell me, all good or it's fine?
All good, sir.
4th, dialogue should result in closure. When you click an system, then there must be a slider which shows 1%, 2%, 3%, and 100%. All the progress is shown, right? So the similar thing must be implemented in your program if any component is required. So all these are actually optional. If anything is required in your prototyping, you can implement that. Next is strive for error prevention. If any error happens, just look at the example that it says that an error happened. It is an error message, right? But the error message is a good error message, this one. For example, the error message says that it cannot be opened because it is from an unidentified developer. And then the next paragraph is actually helping you. It is not put you into the blind situation. It is helping you that your security preference allows installation of one apps. So it gives you the idea that you can go to the security setting and you can change the setting to make it work. So my point is, whenever any error happens in the error dialog, try to put some useful information so that user will not be confused. he can recover the situation. Am I right? Does it make sense? Does it make sense?
Yep.
So in
Yep.
your prototype, please try to put at least one, not more than that, at least one kind of error reporting, error form, like if any error happens, and in that try to put some useful guideline, and then you can mention in the report that you followed this particular principle of Schneiderman, you know, to make your report kind of good report. Then easy reversal of action. This is an interesting one. Is that, you know, you can undo the operation. If you do any operation, you can undo it from the Mac. So similar undo operation, if you can put in your design, it is kind of good, but it is really hard to achieve in practically, but there's an option there. Okay, next, internal locus of control. You know, in your own Windows operating system, if you press Ctrl-Alt-V, you can always go to the control. So if any program hangs, if the program doesn't respond, then using Ctrl-Alt-Del, you can take the control in your own hand. Then you can kill the operation. Similarly, in your program, you must have to have that internal locus of control. Okay, some short key, if you press it, it will actually give the control to stop the procedure and so on. So if you can achieve that, it's an optional. If you can achieve that, then you need to mention that. Finally, reduce the short-term memory. So any design principle, if you follow, for the next version, you should keep the same design principle. For example, in iOS operating system, for every version, they keep four widely used, 4 popular applications in the top, what that user is using, 4, not 5 or 6, right? So this is how they keep the maintenance. So this is part of the consistency, basically. Now, how in your project prototyping can you follow in your assessment too, if you think that out of these 8 principles that we just discussed, which one you can follow in your prototyping? If you can follow 1 or 2 or 3, just mention that. Okay, and give some picture, corresponding picture for that. Okay, all clear? So more needs to be more I can discuss during the breakout room during the tutorial time. But for all other students, I can say that if you can use that Schneiderman principles in your design, then you need to put some additional picture, and you can mention in writing that I had followed only 1 or 2 principles, like offer information feedback and design dialogue closure, these 2 principles into the design, then to make your report kind of give a good shape in your report, right? You can actually mention that, and we can understand that you went through that particular type of user interface research kind of thing. Okay, so I think that's it for today. Any question by anyone? Any question by anyone? Okay, that's good. We actually went through kind of slowly, and I asked in between do you have any question? Now, one thing, can you please utilize this time? I send an email to all of you, right? I'm putting the chat actually. I send an email regarding the feedback. Yes, can you please do it now? Everyone, I suggest, because I need to send that information to the AD. Okay, Associate Dean. So can you please do that? And from 11 o'clock, I'll start the breakout room for my tutorial student, and then we'll go from there. I'll also, I'm right now, thanks for attending today's lecture. I'm sending you in chat the link again so that you can follow it up, please. And from 11 o'clock, we'll start the class. So again, thank you all for attending today's lecture. It was a big lecture. We covered many things, and hopefully it was useful, and it will be really useful when you go into the job environment. And some of the thing at the end, I talked about the 8 principles that you can use in your report. Probably it's an optional. I'm not forcing anyone, but if you can, it's a good point. And also you need to do more research thing into your report as well, whenever you can, to make the quality of the report very high. Okay, see you next week, and my tutorial student, I'll meet you at 11. Okay, thank you all. So in the chat, I sent you the link again. So if you please feel free to give the comment for me so that I can forward it to the AD. Okay, thank you.